Okay, for today we are doing 3.4, which is the last section of chapter 3. We're looking at rational equations and inequalities. So as we go about, we're going to solve each of these graphically and algebraically. So let's start with graphically since we've done that a lot recently. As you look at this function, so let's say, hey, here we've got 2x minus 1 divided by x plus 3. So let's say f of x equals 2x minus 1 over x plus 3. Your x-intercept is setting the top equal to 0, so we get x equals a half. Your y-intercept, you're plugging 0 in for x, and we get negative a third. Your vertical asymptote, we're setting the denominator equal to 0, so we get x equals negative 3. And this one has a horizontal or slant since it's degree 1 over degree 1. It's a horizontal asymptote. And we're going to divide the leading coefficient, so we have y equals 2 divided by 1, which is just 2. Okay, so now let's think about this graph. Let's go through and do it. We've got x is a half, y is negative a third. Okay, then we've got some asymptotes, right? So in this case, we've got x equals negative 3, and y is positive 2. So now as you go through, we can connect these points, right? Draw in your graph, and the other one will be in this upper left quadrant. Okay. In this first question where it says when does it equal 0, okay, that's saying when does y equal 0? Well, it's this line right here, so we're talking about, hey, the x-intercept, right? So at the x-intercept, this point right here is going to be our solution, so x equals a half. When we say, hey, when does our equation equal 4, we're saying, okay, if we go up to 4, this is where it'd maybe be a little bit more important to graph the points exactly. But we're talking about here, and you'd have to determine what that point is. So my graph is not the most accurate on that side. Maybe I should have plugged in a few points. I will point that out. Okay, so that's why, hey, algebra may be more useful for us, right? So whether you cross multiply or you think about just multiplying both sides by x plus 3, we end up getting 2x minus 1 equals 0 times anything is just 0. We add 1 to the other side, so we get x equals a half. Hey, that is the same solution we got when we looked at the graph. If we do the same thing down here, we're multiplying by x plus 3. So we end up with 2x minus 1. As we distribute the 4, we get 4x plus 12. So let's combine. I'm going to move the 2x to the other side, so I get 2x. I'm going to move the 12 to the other side, so I get negative 13. So x equals negative 13 halves. So that means the x value is what, like negative 6.5? So notice my graph didn't quite match that. I apologize. Okay. Let's look at the next one. So it says, solve the following algebraically, check domains to eliminate extraneous solutions. So, on this first one, we would want to make sure that we have one fraction before we cross multiply or get rid of the denominators. So, I'm going to go ahead and make this 8 times, in this case, we want that 5x minus 25 to multiply on the top and bottom, such that it will have a common denominator. Okay, so we get x minus 8 times 5x minus 25 all over 5x minus 25 equals 1 over x minus 5. Let's simplify that top. That's negative 40x plus negative 8 times negative 25, I believe, is 200, and it is. So we'll have negative 39x plus 200 all over 5x minus 25 equals 1 over x minus 5. There are definitely a couple options here. I think cross-multiplying is a nice way to go about solving this. So we'd have negative 39x plus 200 times x minus 5 equals 5x minus 25. Okay, so something I notice here is the right side can be factored, right? I could take a 5 out of both of them. So notice here, if I divide by the x minus 5, you would actually have a factor that cancels, and then I'm left with negative 39x plus 200 just equals 5. So negative 39x equals negative 195. As you divide both sides by the negative 39, we end up with x equals 5. Okay, the thing here is they say check for extraneous solutions, right? So x equals 5 looks like it should be the solution, but notice as you look at these functions at the top, we have a vertical asymptote at 5, right? Our domain restriction says that x cannot be 5. So therefore, this answer does not exist. Okay, if it's easier to say, you could do the domain to begin with. So like on this next one, we could say, hey, the domain restriction on the left is x cannot be negative 3. And on the right, it's x cannot be negative 1. So we know as we saw that if we get either of those answers, just be aware it's not going to work out. Okay, I like to cross multiply up to you here. So we'd have 5 times x plus 3 equals 3 times x plus 1. So we get 5x plus 15 equals 3x plus 3. So subtract the 3x, we get 2x. Subtract the 15, we get negative 12. X equals a negative 6, and that solution does work. It's not extraneous. Maybe I'll label this one as extraneous. Okay, next one. Since you just have one thing here, I usually just multiply by the denominator on both sides. Okay. 2x plus 17 equals x plus 5 times x plus 1. And I notice here on the left, there's not a like factor that cancels out like that first one, right? So I'm going to go ahead and multiply and combine like terms. So x squared plus 1x plus 5x is 6x plus 5. As I subtract things to the other side, and I move like the 2x over, I'd have plus 4x. As I move 17 over, I get minus 12. So now this factors to x plus 6, x minus 2. So x equals a negative 6 and a positive 2. Okay, the only thing you have to do is check to make sure it's non-extraneous. So the only restriction we have at the beginning is from the left side where the denominator, x plus 1 equals 0, so x cannot be negative 1. So therefore, both these answers work. Okay, so now let's do it when we've got inequalities, right? Once again, you could solve these algebraically or you can solve them graphically, right? This first one wants us to go ahead and solve it graphically. So let's go ahead and notice what we got. First of all, I notice, hey, there's a factor that cancels, right? So that means there is a hole at x equals 2 to find that y value. Remember, we're going to plug 2 into then that simplified version, so 2 plus 3 squared, 2 minus 7, divided by 2 to the 4th, 2 plus 10. Okay, this one I'm going to cheat a little bit. Not say it's cheating, but I'm going to pull out my calculator. Up to you if you want to do your mental math, or you're feeling like being a little bit lazier. So here I end up with a fraction of negative 25 over 32, okay? Which is approximately, if you want to know, like negative 0.78. Okay, our vertical, let's go for x-intercepts actually next. X-intercepts, we've got x equals negative 3, and we set the top equal to 0. I think it's important to note that it's multiplicity 2 though, so it will bounce. And x equals positive 7. Our y-intercept here, so when I plug 0 in for x, you're going to get 0 on the denominator, so therefore we can't divide by 0, so our y-intercept does not exist. Our vertical asymptotes are when the bottom equals 0, so x to the 4th is just x equals 0, I am going to put multiplicity 4 there because that does make a difference on that asymptote. And x equals -8. Horizontal asymptotes. Let's look at the degree of the top and the degree on the bottom. The degree of the top is 4, the degree of the bottom is 6. So since the degree of the bottom is larger, y equals 0. It is a horizontal. Okay, so if I start plotting things, we got an x-intercept at -3 and at 7. And then we've got some asymptotes. So we got an asymptote at 0. X equals 0, I should say. X equals -8. And we got an asymptote at y equals 0. Okay, notice here this isn't really enough information for me to know exactly what's going on with this graph. So this is where that number line comes in handy, remember? So on this number line, we are going to put our x-intercepts and our vertical asymptotes. So -8, -3, 0, and 7. Okay, our factors here, right, are the x plus 3 squared, which squared you know is always positive, so you don't have to super worry about that one. We've got an x minus 7. We've got x to the 4th, once again, a 4th degree will always be positive. And an x plus 8. The reason I did not do the x minus 2 over x minus 2 is because those will cancel each other out, right? A negative divided by negative is a positive divided by a positive is also a positive. So now let's plug in something that's less than -8, so like -9. This is a negative and a negative, so this interval is positive. If we choose something between -8 and -3, let's say like -5, this is a negative and a positive, so this interval is negative. Between -3 and 0, let's say -1, we get a negative and a positive again. We got a negative, which makes sense because remember this had a multiplicity of 2, so it should bounce. It shouldn't change there. Okay, and now we have like between 0 and 7, so let's say 1, we've got a negative and a positive. It's negative. Makes sense again because remember this one has multiplicity 4, so it should bounce there. Last but not least, if I choose something like 8, I get a positive and a positive, so this interval is positive. So as I now go to graph it, the far right left interval is positive, so it means it's in the upper left-hand quadrant. The next interval is negative and stays negative, so it means it's going to come up, but it's going to bounce off that point and come back down. Okay, the next one starts negative, but ends positive, so it's going to come up and then down to the asymptote. Okay, in this case, we are looking for when it is greater than or equal to 0. So we want the parts of the graph that are positive. We also want the part of the graph that's equal to 0, and we want the part that's positive again. So as we write our final answer here, we would have, let's see, we would have, okay, the first interval is all the way to the left, so that's -infinity to -8. And we're not actually touching at -8. Union, in this case, if you just want a single point, you actually use the curly brackets. Not that you'll see that very often, but just the point -3, right? That's equal to 0. And then union, the last interval, we will include 7 because that is equal to 0, but to infinity. Okay. So that's how you do it graphically, but algebraically will be easier in many instances. So what we're going to do to solve it algebraically, we're going to move everything to the left side so it's compared to 0. Now you could move it to the right side, but you want it compared to 0. We're going to find the critical points, so all the zeros, your x-intercepts, right, and the vertical asymptotes. So just like we've done before, like we did on the number line above, and we're going to mark them on a number line. We're going to create that sign chart, and then we're going to choose the interval that corresponds to the inequality in step 1. So we're basically just going to focus on this part right here, right? We're just going to make that sign chart is kind of the idea behind it. So here we already have it equal to 0, so that's all set. So we're going to put on our number line our x-intercepts and our vertical asymptotes. So our x-intercept, there is none, right? There's nothing that makes the top equal to 0, but our vertical asymptote is x equals -1. So -1 is the only thing that goes on our number line. In this case, I usually put the factors on the left, so 2 and x plus 1. So this is positive, and so is this. But as you plug in something less than -1, let's say -2, we get a negative. As we plug in something greater than -1, let's say 0, we get a positive. As you multiply a negative times a positive, we get a negative, and then we get a positive over here. While you definitely can plug in actual values, I think that sign chart makes it a lot easier. It kind of simplifies the process. In this case, we want one that's greater than 0, so we're taking to the right, and not equal to, so an open circle. So the interval that corresponds to it is -1 to infinity. Okay, let's look at the next one. Nicely already kind of set up for us. We've got x-intercept of 3, and we've got our vertical asymptote, setting the bottom equal to 0, of -2. So on our number line, we are going to put a -2 and a +3. Now it is to our factors. Our factors are x minus 3 and x plus 2. As we choose something like -3, we get a negative and a negative, but a negative times a negative is a positive. Something between -2 and 3 is like 0. So we get a negative and a positive, so this is also negative. Something greater than 3, like 4, is a positive and a positive, so this interval is positive. Since we wanted, in this case, when it was less than or equal to 0, we want the negative parts, but we are going to include the endpoints here. So our interval here would be -2 to 3. Okay. Oh, you know what I messed up? I messed up something here. Okay, there's one thing we got to be a little careful with here as we write it. This one, technically, I messed up. This one technically would have to be an open circle, because of the domain restriction, right? The fact that a vertical asymptote can never actually be crossed, we can't include that point. So this answer is actually parentheses -3, -2, and then bracket around the 3. Okay, this next one, okay, I'm going to tell you right now, you got to be careful this next one. You have to set it equal to 0. So many people want to cross multiply, and what you end up doing is you end up losing some of the information. You end up only getting like one x-intercept, and you lose the vertical asymptotes, okay? If you do cross multiply, I think there are ways that you can figure it out, but I'm going to make you look for those patterns, right? Be careful, we need x-intercepts and vertical asymptotes, and you're not getting all those if you don't set it equal to 0. So I am going to subtract the 6 over x minus 1 to the other side. It's still greater than 0. So now I want to have a common denominator, so I'm going to have to multiply the opposite on both. Okay. 8 times x minus 1 minus 6 times x minus 3, all divided by x minus 1, x minus 3 is greater than 0. 8x minus 8 minus 6x plus 18 over x minus 1, x minus 3 is greater than 0. So now we get 2x plus 10 over x minus 1, x minus 3 is greater than 0. Okay, the nice thing about that is now I have this rational function, right? I could even factor the top, and I could say this is 2 times x plus 5 over x minus 1, x minus 3, right, is greater than 0. So it's pretty easy now to identify, hey, my x-intercept is a -5. My vertical asymptotes, right, are x equals 1 and x equals 3. Okay, so now as we set up our number line, we are going to have -5, we're going to have +1, and +3. Okay, the factors here we have are technically our 2, x plus 5, which you could also just do like 2x plus 10 if you wanted. You've got x minus 1, x minus 3. 2 is positive on every interval. Now I pick something smaller than -5. Let's say like -6. We get a negative, a negative, a negative. A negative times a positive is a negative, times another negative is positive, times another negative is negative. Okay, we choose something between -5 and 1. We get +5, negative, negative. So this is a positive. Maybe we choose something like 2 for between 1 and 3. We get a positive, and a negative. We get a negative. Maybe choose something like 4. We get a positive, and a positive. So this interval is positive. In this case, we do want the greater than, so we want the positive intervals, but not equal to. So our final answer here would be -5 to 1, union 3 to infinity. I'm going to say this is one you definitely want to know, okay? We see lots of these like on our tests and our quizzes and stuff, right? They like challenge you a little bit more than just the basic ones. Okay, this last one we're going to have to factor. So x minus 4, x plus 3, divided by x plus 3, x minus 2 is greater than 0. Hey, notice there is a factor that cancels. So here we have a whole at x equals -3. We've got an x-intercept at x equals 4. And we've got a vertical asymptote at x equals 2. So this is something I didn't say, but when I say critical points, I guess we want the wholes as well. So maybe I should add that in there. Like a whole is important to note too. And I guess, well, it's up to you. You don't necessarily need the whole on the number line, but we do need to be aware that it is a whole. So it's up to you. If it's easier for you to think about it with it on the number line, you may remember not to forget about it. So I'll kind of show you that, and I'll show you how you could add it in. We definitely want the vertical asymptote and the x-intercept. And we can even use our simplified version, so our two factors, x minus 4 and x minus 2. So if I choose something like 0, right, I would get a negative and a negative, so this is positive. If I choose something like 3, I get a negative and a positive, so a negative, and something like 5, I get a positive and positive, I get a positive. Okay, so in this case, I'm saying, hey, I want all the positive parts. The reason why I'd maybe say to add in your whole at -3 is we would still see, hey, it's positive to the left of that. Right, you could plug in something like -4 and you'd have a negative and a negative. But it may just help you remember as you're writing your interval, right? We want all the positive parts here, but not equal to 0 or not a whole. So therefore, it kind of just shows you that you got to skip over that number. Need to skip over -3 because it's a whole. So if you didn't have that there, you may just have said it's -infinity to 2, but really the answer is -infinity to -3, -3 to 2, and 4 to infinity. Okay, good luck.